Hi and good afternoon. Talking with Irwin Williams, and the topic of today is funky things to do with Azure Functions. Um, so let me just give you guys a little bit about Irwin. Irwin Williams is a professional software developer. He has been developing software solutions at Telesis Systems since 2005, and these days he is into conversational UI, cloud and computer, and development advocacy. And today we're going to be speaking with more about Azure. So welcome, Irwin. Welcome. You need to unmute your mic.
All right,
Yeah.
great. Hey, apologies. Hi, Natalie.
Hi.
I actually was on the call for a little bit and I hadn't, I had my audio muted
Oh, okay.
for
Yes.
a while. I was like, not here. Are we fine?
Yes, we are. So now the floor is all yours.
All right, great. Hi, everyone. Thanks for the introduction, Natalie. As she said, as I heard just at the very end, I do engage in developer advocacy here at Teleo Systems. I'm here at Teleos' head offices in Port of Spain, Trinidad. Pretty rainy day today, pretty overcast. So hopefully it makes really good recording.
Yeah.
So I understand these things. Right. So I said today I'm presenting on Azure Functions, and well, just before I was talking, Natalie did indicate, well, she's had Azure for a while, but not really used it that much. And I imagine there are quite a few people with that similar story. So though I'm talking about Azure Functions, it seems to make sense to spend a little bit of time talking about Azure. So myself and here at Telios, we've been using cloud technologies for a while, probably 6 years or so. And we use it for a number of things to build websites, to produce other solutions. We use it for experimentation because we a lot of our developers are part of the Microsoft Developer Network. We have access to Azure credit every month that we use to build and test and demonstrate ideas we may have. So, what is Azure? Azure is a Microsoft's cloud offering that essentially lets you utilize computing resources on demand, a wide variety of computing resources, from virtual machines to IoT-based websites, and a number of other types of cloud resources. Today, in particular, I'm talking about Azure Functions. So I have a very brief presentation that I'll share, and then we'll get into some code. We will get to see uh, an example of how this works out on the Azure portal as well. So hopefully it may be a bit of a jump for some of us, but it should provide some insight as to how this whole Azure thing works. And I'm pretty excited about this demo because of how it kind of takes a bit of a jump near to the end. So we'll see how that goes. All right, let me just share screen. Natalie, let me know when you can see.
We can see. Yep. Yep. It's up.
All right, great. So I call this presentation Funky Azure Functions because I like puns, and we'll see how this works out. So Azure Functions, what we're talking about today, we'll talk a bit about what serverless is just before we get into Azure Functions. I will come back into some examples of what you can build with Azure Function. During this session, I hope to build an Azure Functions together with you. Mind you, though, I've kind of already built out my working code in case what I build live doesn't work, and there are some tools I'm going to use that you may not have access to, and that's okay. We can just follow along together with me. I am going to be using Visual Studio. I'll be using the Azure portal. I already have an Azure subscription, so I'll be using that subscription to demonstrate the various sorts of resources that we'll use. You may not have these things, but I understand, of course, this call is being recorded, so you could just take it in today, and you can walk through at your own pace later on with the recording. All right, so what's serverless? So you may have heard of serverless technologies in the recent past. It's become very, very hot topic in our industry. As stated above, you write the code, a third party hosts and runs it. Now, mind you, when I leaned on Martin Fowler's definition of serverless. He has a great blog post on it that I'll share with you guys later on. And when you see a third party host and runs it, you might think, but that's similar to just hosting a website. The thing with serverless and serverless type activities, you tend to focus on very specific functionality for each serverless function or activity you're trying to make available for your services and applications to use. It's also called functions as a service. There's a previous definition of serverless that used to be used, but commonly today, when people say serverless, they mean functions as a service. That is, you are using some cloud provider or some other third party to give you the service of getting your functions executed. And it could be as specific as a singular method in an API to run. And all you care about is that the function was executed. You don't care about the VMs or the CPUs or all the supporting resources needed to make this thing run. Because it's functions as a service, you're not locked down to a specific library or function or framework to get functions executed. You could use whatever you are these days familiar with. I'll be demonstrating Azure Functions, but there are offerings from Google called Cloud Functions, and of course Amazon via AWS's. It just slipped my mind, but Amazon has one as well. You can trigger functions via a number of mechanisms. So you might hear of using functions as a service for aspects of your web infrastructure, and therefore implying that you have to use the web to trigger a function. That's not necessarily always the case, and it's bothering me. I can't remember Amazon's serverless offering, so I'm looking it up right now just to tell you, so I feel complete about it. Yeah, it's just called serverless and AWS. Yeah, there you go. AWS serverless. So we'll also drop that in the show notes later on. So anyway, back to our functions. And it's great for horizontal scaling. I do have a really brief architecture to show for what I'm going to demonstrate a little later on, and we'll talk a bit more about what that scaling looks like. So Azure Functions is Microsoft's implementation of serverless technologies or functions as a service. You can define, configure, and deploy functions via the Azure portal, via the Azure CLI, or their web management API. So I'll be using Visual Studio to create my functions and then deploying it via the Azure Web Management API. As I said before, you could also use the CLI. Azure Functions supports execution in .NET, Python, Java, Node, and quite a few are still being released. So, for example, you can do a function in and other languages. In terms of its execution model, with Azure Functions, you pay only when your function gets executed, which is different to say you have a website and you're hosting your website and you're paying for hosting, whether it's used or not. Functions, if it gets invoked, then you have to pay whatever cost it is. No invocation means it's not being used. So it's really, really good for those applications that sometimes, like an API, may get called frequently at some times and then not at all other times. In which case, hosting that API with using a functions as a service model can be really, really good for your bottom line. It could involve. I remember one time I was working on an elections application, and part of it involved pulling results very, very frequently. And what we did was we tied that to an Ajax call pulling from the main website. And as it turns out, I was new to the game and I was excited about the fact that we had this election site, but I didn't contemplate what it meant for a couple thousand users to be making every 5 seconds to my infrastructure. And as a result, as you can expect, my site did suffer some 502 errors. So I was both proud and embarrassed. that my site was popular enough to be brought down, but then it was brought down by my own hand, really, by using an architecture that didn't quite contemplate the kind of popularity you'd see that night of elections. Hopefully, I've since then learned my lesson. Anyway, it is great for executions like that. So in that case, I could have put one part of my API as an Azure function or utilize functions as a service. And for as many requests as I got, the cloud provider would have had to deal with the scaling, as I mentioned a little while before, of my service, my serverless function, so that any hits to that would have been handled by that, and clients would have been happy, I would have been happy. But we're all here to learn, right? So here are some examples of functions. You can use functions for processing requests that are stored on a service bus queue. Azure Service Bus is an example of a resource available in Azure that allows you to queue messages and process them in a particular way. So in this example, we have requests being made to a web app could be dropped on a service bus queue. For another project I was working on, it involved monitoring vehicles as they pass through traffic. I used vehicle location updates. I got updates via a web app, and I dropped it on a service bus so that I didn't have to use the main web app to process the vehicle updates. So in this case here, we can see a request made in a web app could get dropped on a queue, and the Azure Functions execution environment can handle running it, dropping the output in a database. In this case, it's Cosmos DB. In my case, I wanted it to go into a regular SQL Server database and then display that later on. So web application backend is one way to use functions. Apart from that, processing files as they are dropped into storage. I just finished a project like this actually, where I'm processing a bunch of image files. And as the files get processed, they get passed through some machine learning stuff. And I want the output to be used to render the data somewhere else. So as it's shown here, data can be dropped inside of blob storage, which is another resource in Azure. It allows you to store files and images and documents. I put my data inside of the blob storage, and then I have a function that uses a service to detect when files are added to the blob storage and then pass it on. So in this, it's pretty similar to this workflow. My files are dropped into blob storage. It gets picked up by the function, and I actually invoke another web service with the file and store the results in a Cosmos DB. So these things are really good examples of how you could use serverless. And the final example is scheduling. With Azure Functions, you can actually go ahead and schedule when a function should get run. So for example, in this case, it says a function cleans a database every 15 minutes. So you can go up to the Azure portal and specify, I would like to have some activity take place on some given time period. And it really allows you to have computing that is tied not just to web requests, but other kinds of triggers, environmental triggers, as we saw before. You could go ahead and drop a file in blob storage. It could be a file added from some means, some client somewhere is dropping files into a storage system, and you're extracting those files on demand. Or it could be that every period that on some schedule, go ahead and do work. So these are some pretty cool examples, and I want to see if we could build out one or two today. So let's build our first Azure function. Natalie, any questions before I continue?
None at the moment.
Great. All right, so let's build. I'm going to switch. So I'm in PowerPoint. I'm just going to switch to Visual Studio. I am using Visual Studio Enterprise. You don't have to use Visual Studio Enterprise. You could use whatever tool is available to you. You can use Visual Studio Community. You can use Visual Studio Code. And as I said before, you can actually build functions using the Azure portal. So let me build one here. And we'll probably go on the portal and build another one as well in a little bit. So in this case, you saw the example in my presentation a while ago of having a function being able to read data from a storage source, like read from blob storage. Doing that with Visual Studio is pretty easy. And I'll show you what I mean. So I have a blank solution already set up. I can right click and choose to add a new project. And in this case, I'm going to look for Azure Functions. I have Visual Studio 2017, I think, update 5. You may not have that if you download, and if you have an earlier version of Visual Studio installed or an earlier version of VS 2017 in particular. You can just go download the Azure Function tooling. It's an add-on you can run to be a part of Visual Studio. So let's call this function our Q reader. So here, notice as I started off, I'm going to stick with the version 1 tooling around creating functions. You could go with version 2, but we'll see why I use version 1 in a little while. And in this case, I'm going to use the queue trigger. So what it's saying here is when messages get dropped on an Azure storage queue, go ahead and pull that message down and display it or whatever. In this case, we're just going to display it on our console. So here it's asking me for a connection string to the actual queue we'll be reading from, the name of the string. So I'll call this queue. And, the name of the queue. So this is the connection string, and this is the name of the queue in Azure. Let me see. Let's find a good name. You know, one of the hardest problems in computer science is naming things, or so I'm told. Yeah, let's call this grid queue. Call it good queue. Because I think we should just drop goods in a queue and display it. You think about that, Natalie?
Yeah.
So this is the rendering. Essentially, I could stop here, and if I ran this locally, so this is one of the nice things about functions development locally, and this may seem pretty small, so let me increase the font. If I ran this locally, it would pick up on my Azure queue. I need to put in this connection string and go ahead and display any messages that was sent on that queue. So notice this is my configuration. What I did here is I said, create a function and let it pull from a setting called Azure queue. So that means I have to create one. So I'm going to go across to local settings, specify Azure queue. Now I need to get a connection string. I already have one, so I'm going to use it. We'll see how I got it in a short while. Do it over here. Make sure it's pasted fine. Okay. All right, so there's my setting. And now I have a function that will display the item that was dropped on the queue. So if I ran this, so just started it running, we should see the Azure Function tooling pop up. Here it is. So it's just loading up this function in a local function host so I can see it before I deploy it if I choose to deploy it. Great, so it said it found a function and well, it's now waiting to see if any messages get dropped on a queue. So I'm building out a sort of an example here. And if you're following with me, you'll be asking, well, how are you going to write things to the queue? Well, as it turns out, we could use a function to write to the queue as well. So we could even write to the queue based on a message you got via the web. So I just kind of built out a function that could listen on an Azure storage queue. Well, now let's write a function that could write to an Azure storage queue. A little more complexity. But just so you see it run, I actually have one of those functions already, and I want to just get messages on the queue immediately. So I'm going to start up that function to get messages on the queue to see this displayed, and then we'll build it out ourselves. Right, so here's the Azure portal. And if I go to function apps, I wrote a function called grid and queue. Here it is. And it's one function in this particular function app. And it's an HTTP function. You'll see how I build this in one moment. So if I get the function URL here, go ahead and say and good. Well, here, see, I'm going to call this function with a good at the end. And you can say it said hello to that. But if you look at my guy here, we're waiting to see if he picks up on that good. And you can see here, it just executed a new queue message detected on the queue. And let's see what happened there. So queue trigger function process with queue item. And that's what he would have said to our log. So let me stop this. And let me just show you quickly what this writer function look like. So let me add a new function. Add new project. Gonna go out, add other functions and call this one queue writer. And this one instead is an HTTP trigger. Now notice the default code it gives us reads a value from the query string or from the body, and that value is expected to be called name, and then it will go ahead and respond indicating if it got that value or not. What we can do with that value is just go ahead and dump it on an Azure storage queue. So let me pull back up the Azure portal I was just showing off. So here at the Azure portal, you have a number of resources available. I'm using resources are arranged in resource groups, and I am just using this particular one. So for this particular resource group, you see a number of resources defined. There's a service plan for a web app. There are storage accounts, application insights, and of course, Azure Functions. What I'm doing is writing to an Azure queue that was defined in one of these storage accounts. In fact, it was defined in this one called function operations. So here, you can see the storage account. And if you scroll down, you'll see here under queues, the queues available in this account. So I knew I wanted to read from a queue. So before this particular cast, I went ahead and made a storage account and ensured that it was available so I can use it for this demo. Making a storage account is pretty trivial. I can just show you really quickly what I did. I went to my resource group. I chose to add. And after adding, I chose Azure Storage. So I searched for Azure Storage, and these options here present a number of storage type resources to get created. I chose, I don't see it here. Let me remove storage Azure from the name. Storage account. Yeah, so I chose to create this one. I wouldn't make another one because I already have one. And in so doing, it gave me the account that would contain the Azure queue. Great. I have the Azure queue. Now I want to write it. In this case, I have a bit of code that I wrote before this meeting, and I'm just going to drop it into our demo. So here's our demo, and this is the one that will write to the queue. So because the web is what the web is, I'm only interested in displaying GUIDs in this presentation. So I'm going to get a GUID via this parameter and go ahead and using these objects write it to the queue. I get a representation of my storage account. Notice I need a connection string, which I used before. The same connection string up here, I used before to register interest in receiving messages from the queue. So just copying that from where we had it, this. I have connection string there. I set up a client that's going to simply give me a reference to the queue if I need it. We had a name for the queue already, var queue name equal to queue. And that's what it does. It goes ahead. It writes to the queue the GUID that you just saw. And as we saw also a little while ago, when it's written to the queue, our function will read that. So I mentioned a few scenarios. If we go back to my presentation, I mentioned a few scenarios that seem really ideal for serverless workflows. So we saw right now, I just built a demo that could display messages that went to a queue and receive messages from a queue. Now, this is jive. This is pretty cool. I dig it. But I'm really into Azure Functions because it represents the ability to sort of have execution on demand. You could create what you want and have it executed by a cloud provider. You don't have to worry too much about how they'll get it run once they have the ability to run it. And that's exciting to me. So yes, you can write manual functions for these scenarios. And these are good scenarios. This is Jive, timers and real-time processing and backends. And there are many more things you can and should do with functions. But one of the things that excited me recently was understanding that this computing on demand is not necessarily, it's not limited to the code you've written and compiled. You can write code on demand that gets executed on demand. which to me is exciting. That's the funky stuff. So I built 2 functions already. And there's one more I want to kind of talk about this evening. I already wrote it. So I want to kind of take you through it because there's a bit of a ramp up. If there were a curve in this conversation, the curve would probably look like this. There's a point, and then there's another point, and I'm going to cook all the way over here, and I'm not sorry at all. Let's see what I mean. All right, so I have another Visual Studio solution. Notice I have a thing called, in my mind I was playing the concept of something called a plant and cure. Plant water, sorry. So let's kind of go to the architecture first. So I'm saying, what if you had this system that needed to water several plants with different schedules? Then how would you build it using something like functions? And how would you allow someone to kind of configure the schedules on demand? You can, in fact, go to the Azure portal. Let's head back there. You can go to the portal and add a new function that is a timer. So you saw me just create a function that was HTTP triggered, and then I made another one that was queue triggered. I could also come to the portal and make another kind of function that is a time-based function. So I choose function app here, and if I go through to configure it, I have to kind of get past all this stuff of defining to Azure where like the function to live. So in this case, I'd call this carry dev 2. Leave most of the stuff as default. I tend to use the EastUS because it's near to us here in Trinidad. And I choose create. So what this will do is go ahead and create the host for my function app to be defined inside of. It'll take a few moments. And when it's done, I can go ahead and click through to it. So while that's happening, let's talk about what this architecture looks like. So we're saying set up something that could receive configuration information for functions, and then create each function based on this configuration. And then based on their timing, they'll wake up, they'll invoke a third function that drops stuff on a queue to be received for watering a plant. There are no plants involved. I wish I could have shown you that at this moment, but I don't have the stuff for that. So I'm just showing you the scenario that could involve watering plants when really all we're watering is goods. Are we good at that? Natalie, we fine?
Yeah.
Nice. So this is our architecture. Let's head back over to see what that looks like in code. So this guy is still being created. Yeah, not too worried about that. So in Visual Studio, this was our basic demo, and here's our less basic demo. So you saw me create something that could write to the queue. That's this function here. Notice he saw this just a while ago. He gets a good and drops it on a queue. That's all, and not even 10 lines, and you're writing stuff to a queue on Azure. Then you saw me create something that would read from the queue, what I'm calling the plant waterer. And all it does is gets a good from the queue and says, hey, I watered this plant. Nice, fine and dandy. What is currently my source of great excitement and coolness is that I could use Azure to create functions. And this is what I did. So I wrote a bit of code that both allows some management for my excitement as well as delivering the cool thing. So let's walk through this code. I get a parameter from the web request. This parameter is an old function ID in case I wanted to delete something I just created, because I'm going to make functions on demand, like with code. And in this case, here's what I'm doing. If I didn't get this ID, I'm not going to delete anything. So I'm going to create. So I'm going to get a schedule because it's a timer function. And for this particular conversation we're having, I'm just going to use this fixed schedule every 3 minutes, wake up and do things. In real life, the schedule might come from any number of places. In fact, I could pass the schedule as part of a parameter in the web. I just chose to keep it simple for the moment. This good represents the thing to get invoked, the data to get dropped onto the queue, along with some of the parameters. And all these parameters are used in a method called create schedule. I'm sorry, friends, if this is your first time talking about Azure or talking about serverless or talking about Azure Functions. It's going to get very gnarly. If I jump into create schedule, look at what's going on. Remember I said you could have different platforms and frameworks using Azure Functions? Well, one of them is JavaScript or Node. So this function is an Azure function and it's written in C#. But this Azure function written in C# can be used to write an Azure function written to run on Node. So how does that work? A Node function can be as simple as two files, index.js file and a function JSON describing the schedule the function should run on. And that's what I do here. In create index, I literally create JavaScript content that will get saved as a file. And if you can read this code, all it does really is invoke a web request. This function to invoke is a URL I'm going to pass to it. And you see this get content method. All it's doing literally is invoking a request, a web request. So it's not super secure. It's not meant to be. It's meant to be a demonstration. This code could have been more complex, but for the moment, it'll just invoke this website. But that website is a function, and that function can store stuff on the queue. So let's look at our architecture to confirm what I'm saying. One of these guys can invoke a URL with a particular parameter, drop the parameter on the queue, and then the plant gets watered in our conceptual world. So how is it doing that? So this is the function that we're creating. So we get the index. The JSON contains the schedule. I do some string magic, which I'm slightly embarrassed about, but not too embarrassed. And what it does is it creates the requisite JSON definition that contains a timer. We'll see what that looks like when my other function is finished. And now, here's the magic. I'm sneaking into something here that's a big deal. It's the Fluent API for Azure. Very, very briefly, this is an API, an SDK that lets you perform Azure management functions in C#. It's kind of like you might use a bash script to manage servers, or you might use PowerShell to perform functions on VM somewhere. It lets me do that stuff in C#. And what I'm going to do is first of all, I'm going to create a zip file. Let's create a zip file in memory. That's pretty simple stuff. Upload that zip to an Azure storage account. That's the basic stuff. And that happens here. Create zip, upload zip. But then this Azure reference I get here, it comes from an Azure Service Principal account I made before. I'll send that stuff out in the show notes. But the point is, this guy can go ahead and look at line 85. It could go ahead and define a new function name in a particular region on a resource group, making a new account with these settings. When it's finished, a new function will be born. And that function can go ahead and wake up on intervals and send out messages. I've already run this once. And if you go across to the portal, we can take a look at what that looks like. So I go to Function Apps. And the one I just started to make is here. This is one from before. And this is the one that I made using a function. So this function was made. So the previous function begat this function. Super biblical, I'm sorry. This function made this particular one, the one before. So you can see here, I'm using some Azure features that I want to talk about, but it's a bit too much for the conversation. So notice this is my function index.js. It's going to call this URL, and it uses this particular schedule. It runs every 3 minutes. I hadn't configured it to to show execution times. So it may not have any data to show here, but it should have run every 3 minutes. So this is loading up. Yeah, nothing to show just yet. In the meantime, here's the function I started to create, the carry dev timer, and no functions defined in it. So what I did, I'm going to do manually here what I did programmatically. When I say create new, I'm going to choose a timer. I choose JavaScript as my language, and I choose create. So this function will run on a timer. I just changed out this code, and my code instead executes an HTTP request. And the schedule for this is every 5 minutes. So if I choose to save this, then this function will run the next 5 minutes from now. And that is my demo and excitement in Azure Functions. So if you have any questions, I'll take it now.
Okay, well, so far nobody has questions, but I do have a question. Could you explain how does one actually set up the Azure account? Because I know they offer free accounts, the free credits.
Yes.
Yeah, so just explain where they go to set up their account process.
So with your favorite search engine, and let me get a different browser so that the experience will look similar. Create new Azure account. It should take you to the Azure portal page to set up. Oh, not that guy. I like a question a lot because there are, take me to the same place. There are a few options for us if we're making Azure accounts. Sign up, there it is. If you're a student, like in university or in secondary school, or you're doing some course of study, you actually have access to free Azure credit for a year, and I believe it's $100 US of Azure credit. If you're signing up to try it out, so if I log in with one of my accounts, it'll say to me, "Oh, and you already have an account." But signing in here should kick off the process. If you are simply trying out Azure, they give you $200 credit to play with that is available for a month, I believe. As I mentioned, I'm part of the Microsoft Developer Network. So every month I have access to $150 of Azure. Once you do that, then selecting whatever account you select, whatever approach you select as a student or free trial or MSD, or just buying an Azure subscription, it then gives you access to the portal, like you saw me using here, and you can make any of the resources listed.
Okay, and I know they also, after that, they also offer you a pay-as-you-go subscription base. So you pay for what you
create. Exactly. Every resource you create, you pay for. In the context of functions, that's a nice thing. You can make a bunch of functions, but if they don't get invoked, then you won't pay for anything. You'll pay for the storage account, which is really minimal. If you want to kind of get a sense of how much things would cost, then going to the Azure calculator is a good next step. Azure calculator lets you get an understanding of how much it would cost to deploy a particular set of resources. And I want to just show as an example how the pricing works for Azure Functions. So I just came and selected Azure Functions. And you notice here, it says the first 400 gigabytes per second of execution. This is a processor-based measure. And the first 1 million executions are free. You could think of this like an API. If you had an API, and the API got a couple 100,000 executions in a given time period, you wouldn't get charged anything. So this relates to Azure Functions. There are other resources like virtual machines and Azure storage accounts that you could also drop into the calculator And as you specify that amounts, it will indicate how much it costs.
Okay. And well, you have 15 minutes. So any other things you'd like to discuss? I'm just waiting to see if anyone has questions. No questions so far, besides myself.
That's cool. I'm very, very glad to have presented. And nothing more to add from me. I'm just really glad that you guys, this is you and Lasana, started this push for this. I'm looking forward to more of these kinds of events. It's exciting to hear what we're building, what we're playing with, what we're excited by. And let's continue to build Caribbean development.
And I have one question again in concerns to Azure.
Sure.
As doing web development, how feasible is it to utilize Azure for web development purposes, like hosting websites? That's my,
So, so
yeah.
as I said, Tele uses Azure both for production and uh, for experimentation. It's if you're building, there's a lot of guidance as to how to manage your costs in Azure. People tend to ask a lot about how much does it cost, how would I keep my costs down. There's a lot of guidance. Some architectures work better than others. So as long as you are going after your solution with a good, a sound architectural approach, you should find yourself very, very glad for one, the reliability of Azure and Azure's resources, as well as the availability of the set of opportunities to build and build amazing things. So, in terms of cost, you can manage your cost really well by building with sound design in mind. And beyond cost, though, you can leverage Azure for things like reliability and capacity. As long as you're building sites that have a particular level of demand in it, if I go back to that elections example, we were just hosting on a regular host provider, and we maxed out the host provider, and we were still finding ourselves being uh, receiving HTTP 502 errors. I'm sure if we were to use a cloud provider, the ability to scale both up and horizontally would have
Yeah.
been very, very good.
Yeah. Oh, yeah. Because that's my concern where we came from. Just you pay for hosting and you pay a flat fee with the Azure. It's the monitoring of the fees. How do you tell your customers? So
So you can restrict it. You can actually say you can set up accounts that only this amount of consumption and no more. You can set up Azure App Services and indicate I'm using a Azure Basic or an Azure Standard S1, and keep the cost within that pricing tier.
okay, great. So as if you can just go back to your Azure platform and just give like a little, as we have the time, just give a brief outline of the different functionality, the different features that one can utilize Azure for. You spoke about function storage. I see there's virtual.
So there are many, many, right? Um, So in this brief example, I spoke about Azure Application Insights, which is a really good mechanism for monitoring your solutions, both web applications, virtual machines, and other kinds of resources. So it's not limited in terms of what you monitor, just that you have all this monitoring available. I spoke about Azure Storage, but I only mentioned Azure Queuing, and I briefly talked on Azure Blob Storage. There's another kind of storage, Azure Cosmos DB, which is a way you can store JSON documents and be able to query them via SQL. If you've used JSON at all, you have a lot of flexibility in terms of the kinds of types that a JSON document may be given to you as. Sometimes it might have fields and mightn't have fields. Cosmos DB lets you query that using regular SQL syntax, which is pretty amazing. Beyond that, there's regular NoSQL table storage available on the storage side, as well as SQL databases. I use SQL Azure a lot. You can use SQL Server in a VM in the cloud, or you can use relational database as a service via SQL. And I guess the last thing I'll talk about is Azure containers in Azure. I just finished a project using Azure container instances, which allows you to have containers on demand, not containers running in a VM that you have to manage. You simply have containers you can run, and deliver functionality, and you only pay for when the container is running. So it's like how Azure Functions, you pay for execution time. With containers, you pay while the container, for Azure Container Instances, you pay while the container is running. So for me, it was a really nice introduction to using containers in production, which I just finished in that project. There are a lot of resources. I don't think I have enough time to go through all of them.
Well, there you go. So I think people should check out Azure. So can you just let people, if they want to reach out to you, just give us a quick, how do they could contact you? I know they can contact you through Caribbean Developer. You're there, but you can.
You can head up to my website, irwinwilliams.com,
Okay.
and there's you can check there. You can get onto my blog or
Oh,
Twitter or anything like that.
okay, cool. So any last words before we wrap up this morning session, I should say?
And none from me except let's keep building together, guys.
Okay, thank you very, very much. And guys, later on this evening from 5 to 6, we will be having Shannon Clark, and he's going to be talking about coding decentralization apps on Ethereum blockchain. So thank you again, Irwin, for the time taken, and hope to see you or hear from you again. We are on at Saturday Open Forum. So,
Great.
okay, so you have a good evening.
Thank you.
Bye.
Cheers, Natalie.
Bye.